you would also want to say we don't have very many data points, so with more data, that might not be the case. It might just be a weird sample. And so that's kind of how you'd want to talk about that scatter plot. But generally, you can see that there is a slightly upward trend. Okay. And then, so we want to interpret the meaning of beta naught and beta 1. So does someone want to try to interpret beta 1 or beta naught, so the intercept, and what that means? I'll make that easier. Yeah.
That's a 9.366.
Yeah.
It's saying that if you didn't have any training, you would still be performing at that level.
Yes. And so, I mean, he doesn't really explain what these, oh, so it's performance time.
Of factory workers.
Oh, the factory line workers. Okay.
Okay, so your performance time if you had 0 hours of training.
Right. Yeah. That's exactly right. And so, we don't really know if that makes sense or not, because we don't really know how hard being a factory worker is, and maybe it is something you could come in at this relatively low level. So you can't really say for that one how much it makes sense, but you would say the model estimates that with 0 hours of training, you would still perform at a 9.3 level, or so perform in 9.3 minutes, whatever you're producing. Okay. So then does someone want to try interpreting beta 1? Yeah.
So I think that means that for every 1 hour of training time you add, can you move the little arrow guy because I can't see it? It increases your performance time by 0.33 minutes.
Yes.
Okay. So really by a third of a minute, or by?
Yeah, so about a third of a minute.
Okay, so not by a lot. I train for an hour and I get 20 seconds better?
Right. Yeah, so if you increase training by 1 hour, you'd improve performance time by 0.33 minutes, which might actually be a statistically significant amount because you work several minutes during a day. So you're improving your time by a somewhat significant amount because you're probably working 8 hours a day or something. So you definitely always want to keep in mind what the units are to see if something's significant or not, because that hour could actually be saving a lot of time over the course of a couple weeks or something. So I think we would say that is a real world or politically significant number.
So if you increase training by an hour, increases performance by a third of a minute, is that what we said?
Yes. Okay. So then the next one is what is its p-value? So that would be this number right here. So what does that mean? Does anyone want to try that one?
Pretty small, so I'm guessing probably going to reject the null.
Yeah, and so it's 0.001, so you could say at the 99% confidence level, we reject the null hypothesis that beta 1 is equal to 0. And so then...
So can you just stop for a second? So the p-value is really the complement of the percentage that we are sure that we can reject the null, fail to reject the null. Sorry. Can you just say that again?
So it's basically any number, so the p-value tells you any number, so you'd want to look at the complement of the p-value.
Which is really high in this case.
Yeah, which is really high, and so at any number lower than that number, you would reject the null hypothesis still. And so...
so in this case, are we 99% sure that we can fail to reject the null?
No, because it's
sorry.
So at 99%, that's going to be slightly lower than the complement of that. And so we would be 99% sure that we can reject the null hypothesis.
That we can reject the null.
Yeah, and so the p-value is the number corresponding to the t-statistic we're given. And so that's 3.89. And so we have 3.89 right here, negative 3.89 right here. And so that number corresponds to having, I guess, 0.00. Okay, so that number would be corresponding to have half of the p-value in each tail, because it's a two-tailed test at that t-statistic. And so we'd have 0.0005 about 5 there, 0.0005 there. And so basically at any t-statistic that's lower than that, so this is going to be higher than the 95% level at 3.89. And our critical t-statistic at the 99% level, we could find with our t-chart. And so we have 20 observations. We're predicting 2 beta values, so our degrees of freedom will be 18. And then if we're doing 99%, we're going to go over to t sub 0.005. And so we have 2.88 is our critical value. And so this would be the 99% level, where we have 0.005 in each tail. And so it's basically any t-statistic lower than 3.89 is where we'll reject the null hypothesis, if that is our confidence level. And then anything above that. So if we wanted to be even more sure than this, so let's say we were going to reject everything below 4, then in that case, that would be in our fail to reject zone. So does that kind of make sense?
I thought the inside was fail to reject and the outside was reject.
Yeah, and so then if we were using 4 as our cutoff point, so that would be greater than 99%. It would be 99.99 something percent. And so that would move 3.89, which is our t-statistic corresponding to our p-value. That would put that in the fail to reject region.
So
any t-statistic lower than that, which is going to be all of the standard ones, like 99 and 95 and 90, that's going to be below our critical value. And so then it would be in our reject region instead.
So below the critical value, which is the 2 lines, is reject, and outside of them is
so
inside is fail to reject.
So this is reject.
Okay.
And fail.
Thank you.
Reject. And this is reject. So you reject in the tails and fail to reject in the middle. And so this number is basically telling us that we have a number that's fairly close to 0, and even at a 99% confidence level, we still fail to reject the null hypothesis. And so this is statistically significant at the 99% level, you could say.
Okay.
Yes. So does that make sense? Hopefully.
Kind of, mostly.
We're rejecting, right?
Yes. Well, so this information doesn't tell you whether to reject or fail to reject. It just tells you at what levels you could reject or fail to reject. And so this tells you that at anything but like a really, really high confidence level, you would still reject the null hypothesis. So this one isn't quite as close to 0 as our last one was, but it's still really close to 0, close enough to 0 that at any of our standard numbers, we would reject the null hypothesis.
Even at the 99%?
Yeah, even at the 99%
Okay.
level.
But
So the p-value tells you your percentage confidence, but not whether you're rejecting or failing to reject.
Right. You need to decide what confidence level you're looking at before you can decide whether to reject or fail to reject.
Okay.
So hopefully that makes sense.
We'll just talk about that.
It will.
Okay. So then talked about are how to do the hypothesis test. So just to remind